Hello, ladies and gentlemen. We are going to do section 4.4. Okay, our objective is going to be solve a quadratic by factoring. All right, that is our task for the day. See if I can get us some more light. Oh, so much better. All right, so we're going to solve a quadratic by factoring. All right, so most of what we're going to do today is review, but we will spend a little bit of time on new topics. All right, so let's start off with an example. Our first example says to solve, and we have an equation that says 5x squared minus 17x plus 6 is equal to 0. All right, remember that since it is a second degree polynomial, I'm going to have two solutions. All right, so I'm going to factor, and I'm going to use the AC method. All right, so the first thing I'm going to do is A times C, so I'm going to have 5 times 6, and I'm going to get 30. And I need the factors of 30 that add or subtract to give me a negative 17. Both can be the same sign, so it's going to be a negative 15 and a negative 2. Then I'm going to rewrite my term, so I have 5x squared minus 15x, and then I write plus a negative 2x plus 6 is 0. I'm going to group and group. These two have a 5 and an x in common. When I take it out, I get an x minus 3. I'm going to take a negative 2 out of the second 2, and I'm going to get x minus 3. And then these two have an x minus 3 in common. When I take it out, I get 5x minus 2. And now I can solve. So if you'll remember from what we did last week, we know that each of these represents a baby equation that needs to be solved. And if you can go directly to x is equal to 3 and x is equal to 2 over 5. If you need to show your work for these, you can, which would be x minus 3 is 0, so x is 3, and 5x minus 2 is equal to 0, 5x equals 2, and then x is equal to 2/5. Whatever works best for you is fine. I tend to not show my work at this step because the equations are very simple, but if you need to do that work, then you should do that work so you don't make mistakes. All right, so let's move on to another example. Here is our second example, and again it's going to say to solve, and I'm going to get 3x squared plus 20x minus 7 is equal to 0. So this is going to be our second example for the day. Again, I'm going to factor using the AC method. And the reason that I'm choosing to do the AC method is because I have an A, and the leading coefficient makes the problem a little bit more entertaining. So if I do my A times C, I'm going to get 3 times a negative 7 is a negative 21. And the factors of a negative 21 that add or subtract to give me 20 are going to be a negative 20, let's do a positive 20 and a negative 1. All right, so that gives me my factors. Then I rewrite 3x squared plus 20x, and then plus a negative 1x, and then minus 7 is equal to 0. I'm going to group these two and these two. Okay. Oh, and I think I just made a mistake. These factors should have been a negative 21 and a positive 1. Sorry, that was my bad. And then this should be 21, and then this is the negative 1. And I knew that because when I wrote this down, and actually it's going to be positive and negative, when I wrote it down, I didn't have common factors. So that's how I knew I had made a mistake. So now I can factor. These two have a 3 and an x in common. When I take it out, I get x minus 7. I'm going to factor out a negative 1 from these two, and I'm going to get x plus 7. Seems to be a difficult brain day. These two now have x plus 7 in common, and when I factor that out, I get 3x minus 1. And now I have my two baby equations that I can solve, and I'm going to get x is equal to a negative 7 and a positive 1/3. So I get x is a negative 7 and a positive 1/3, and then those would be my two solutions. And then if we go back up here and box our two solutions. All right, so none of this is new, just lots more practice. Let's do another example. This time it's going to be slightly different. I'm going to solve 9x squared minus 64 is equal to 0. So when I solve this one, this is a difference of two squares. So I could factor it, but I'm going to show you both methods. I could factor, or I could divide, take the 64 to the other side and divide both sides by 9. So let's start with factoring. 9x squared is a perfect square, and it's 3x, and 8 is a perfect square, it's 64. So I'm going to have plus 64, and 3/8 minus 64 is equal to 0. My goodness, my brain's not working today. If I solve both baby equations, I get x is equal to plus or minus, and then 8/3. Alright, if I had chosen to solve this the other way, I would do 9x squared is equal to 64. I would divide both sides by 9, and then I would get x squared is equal to 64 over 9. Now I'm going to take the square root of both sides, and I would get x is equal to plus or minus. The square root of 64 is 8, and the square root of 3 is 3. So either way I get the same answer. Alright, as we move along, we will do another example. So let me get us a new sheet. Alright, so for our next example, I want to solve, and it's going to be 3x squared plus 10x minus 8 is equal to 0. And again, I'm going to do the AC method because I have a leading coefficient that's not 1. So when I do my AC method, I'm going to get 3 times a negative 8 is a negative 24. And the factors of a negative 24 that give me 10 are going to be a positive 12 and a negative 2. So then when I rewrite my main equation, 3x squared plus 12x, I'm going to write plus a negative 2x minus 8 is equal to 0. I'm going to group and group. These two have a 3x in common, and I'm going to get x plus 4. These have a negative 2 in common, and I'm going to get x plus 4. Now these two expressions have x plus 4 in common, and then I get 3x minus 2. Now I have my two baby equations, and I can solve to get a negative 4 and a positive 2/3. And then that particular equation is done. So really nothing new today other than just some more practice on solving by factoring. Alright, so now let's do a word problem. We haven't done a problem like this for a little while. We actually haven't done any on the video. But we're going to do this particular problem, so I'll write it down, and then I'll pause and let you look at it and make sure you have all your words written down. And then we'll draw the diagram, and then we'll solve the problem. Alright, this particular problem says you have made a rectangular quilt. All right, so you have made a rectangular quilt. It is 5 feet long, and it's going to be 4 feet wide. It says you want to use the remaining 10 feet of fabric to add a decorative border of uniform width to the quilt. Ooh, that's a lot of writing. Alrighty, our last piece of information is the question, what should the width of the border be? Alright, so I'll give you a moment to make sure you have all that written down, or to write down your key pieces. Alright, and now I'm going to draw our diagram. So here's our quilt. Okay, it's lovely. I'm actually sitting at my sewing table right now, so it makes me think about quilting. It's 5 feet long, and then it's going to be 4 feet wide. And then I'm going to put a border around it all the way around, and it's going to be a consistent distance. So this distance is X, that distance is X, this distance is X, and this distance is X. So the length of this side becomes 5 plus 2X, and the length of this side becomes 4 plus 2X. So now, since we're talking about area, I'm going to write an equation for the area of my quilt. So the area of the quilt is going to equal length times width. So it's going to equal the 5 plus the 2x, and then it's going to be multiplied by the width, which is 4 plus 2x. Okay? And then I'm going to expand this right here to make it look like an equation that we're used to dealing with, and I'll do it in a little box over here. Here's my box. I have 5 and then plus 2x and 4 plus 2x, so I get 20, 10x, 8x, and 4x squared. When I combine my like terms, and I'm going to write it in standard form, I get 4x squared plus 18x plus 2. So that is our equation for the area of our quilt. So now what I'm going to do is I'm going to kind of manage the rest of the information that they gave me. They told me that the remaining fabric is going to be used for the border, and it is 10 feet. So we're going to assume that's the area of the border. So I know that the area of the border is going to equal the area of the quilt plus the border, which is what we just calculated, minus the area of the quilt by itself. So it's going to be the area of the quilt and the border minus the area of the quilt. Well, the area of the quilt is going to be equal to 5 times 4. This is my inside piece in here. This is my quilt. And the area of my quilt is going to be 20. Okay? Alright, so I'm going to substitute in the other information that I know. So I know that the area of the border is 10. I know that the area of the quilt and the border is 4x squared plus 18x plus 2. And then I'm going to take away the area of the quilt. Okay? Alrighty, so now I'm going to solve this quadratic. I can't solve the quadratic though until I take the 10 to the other side, and then combine like terms. So I'm going to get 0 is equal to 4x squared plus 18x plus 2 minus 20 and minus 10. So this equation simplifies to be, whoop, that's a 20. I'm sorry. Thinking, how come my numbers aren't working? Alright, so there's the 20. Here's a 20. So when I have the 20 and the 20, they cancel. So my equation turns out to be 4x squared plus 18x and then minus 10. Those numbers are all divisible by 2. So I'm going to factor out a 2 to get 2x squared plus 9x minus 5. Then I can divide both sides by 2. And I'm going to come over here to finish. So I'm going to get 0 is equal to 2x squared plus 9x minus 5. Now for those of you that are good at guess and test, I'm going to do guess and test. So I'm going to write my 2x and my x, and if I put my positive 5 here and my negative 1, I get 10 minus 1 is 9, and that gives me my 5. So I get x is equal to a half and a negative 5. But one of those answers doesn't make sense. The negative 5 doesn't make sense because I can't have a length of material be negative, so the appropriate answer is a half. So that's going to be the width of my border. And because we need to include our units, it's going to be x is equal to 1/2 of a foot, which is the same thing as 6 inches. So that's going to be the width of my border. Alright, so here's most of our problem. I'll give you a couple minutes to look at it. Alright, all we have left now is to give you your problems for the day. You're going to have 4 problems today. So here are your problems, are your 4 problems. Alrighty, the first set says to solve the quadratic. So number 1 is going to be 14x squared minus 21x is equal to 0. This one's a little bit unique. Alright. Number 2 is 4x squared minus 20x plus 25 is equal to 0. Number 3 is 15x squared plus 7x minus 2 is equal to 0. So you will want to solve those 3 quadratics. Remember that they are second degree polynomials, so they will all have 2 solutions. Then your last problem says find the zeros of the function by rewriting the function in intercept form. Alright, so find the zeros of the function by rewriting the function in intercept form. So your fourth problem says g of x is going to equal 3x squared minus 8x plus 5. And I'll give you a hint. You should factor the right-hand side and then you're going to put in intercept form, which is what factoring will do for you, and then you can find the zeros. And remember that we use the words zeros, solutions, and intercepts They all mean about the same thing. All right, so zeros, solutions, are intercepts. And those are your problems. Good luck.